Here's the solution to the problem from the last video. The first part was to prove that in a triangle, the three seam medians always intersect at one point. But this is kind of obvious if you change your perspective and look at this triangle instead. Because in this triangle, this line, and this line intersect at the Jargon point. And therefore, in this triangle, this seam median, and this seam median intersect at the Jargon point of the large triangle, which is the lim1 point for this triangle. According to the optional problem after element 17, if we inscribe a rectangle in the triangle, then the center of the rectangle, or the intersection point of its diagonals, always lies on the line defined by the midpoint of the side and the midpoint of the altitude to that side. So we just need to prove that the lim1 point is the center of such rectangle. So here's our lim1 point marked in blue. This is our triangle, and this are the medians in the triangle. The line connecting this vertex with the lim1 point is a seam median in the triangle, and therefore it's isogonal to the median. And so this angle equals this angle. And for the same reason, we know that this is a seam median, and so this angle equals this angle. Now I'm constructing two lines, this line and this line, that pass through the lim1 point, and that have the property that this angle equals this angle, and that this angle equals this angle. Now we know that this angle plus this angle plus this angle is 180 degrees, and so from the sum of the angles in this triangle, we conclude that this angle equals this angle, and from the sum of the angles in this triangle, we conclude that this angle equals this angle. And so this triangle and this triangle are both similar to the large triangle, as you can see. Now take a look at this triangle and this triangle, which is similar to it. We know that this line is a seam median in the large triangle, and therefore it's a median in the small triangle. Because you see that in this triangle, if we take the median, then it would make this angle here, which would be equal to this angle here, because this is a seam median, and the median and the seam median are isogonal conjugates, and therefore this angle equals this angle. But now you see that this triangle becomes similar to this triangle, or in other words, this point and this point are actually corresponding points in the two similar triangles, and therefore this point must be the midpoint of this segment, as this point is the midpoint of this segment. Now, this here is an isosceles triangle, and therefore this equals this. And finally, take a look at this triangle, and this triangle, which is similar to it. Since this is a seam median in the large triangle, it must be a median in this triangle, because this point, the midpoint of this side in this triangle, corresponds to this point in this small triangle. Because of the angles, this angle equals the corresponding angle here that the median makes with this side of the triangle. So in other words, we get that this triangle from this vertex to the midpoint is similar to this triangle here. And therefore, this point must be the midpoint of this side. And now you see in this triangle, this is a median, and it equals half of this side. And therefore, this triangle must be a right triangle. Similarly, this triangle is a right triangle, this triangle is a right triangle, and this triangle is a right triangle. We have right angles here, here, and here. And so this here is the desired rectangle because its intersection of the diagonals is the lim1 point. There actually exist two more rectangles that are inscribed in the triangle and such that their center is the lim1 point. One is here, and the other one is here. I'll leave it to you to find out how to construct them. These 6 points make a circle, and the center of that circle is the lim1 point. Another question that I'll leave for you to solve is, if you have a triangle and you choose the lim1 point, and you draw the 3 lines parallel to each side of the triangle through the lim1 point, then why those 6 points actually also lie on the same circle? Here's the problem for the next video. We have a triangle ABC, and we chose a point D on the side BC and the point E on the side AC. And then H1 is the orthocenter of triangle EDC, as written here, and H2 is the orthocenter of triangle ABC, as written here. M is the midpoint of the segment EB, and N is the midpoint of the segment AD. We should prove that H1, H2 is perpendicular to MN.